inverse of a matrix. Let us refresh. By inverse of a matrix, we are looking at the inverse of a square matrix A, and is denoted A raised to power minus 1. This actually is pronounced inverse of A. Now, I have used the word square to indicate that you can only find the inverse of a square matrix. A square matrix here is when the numbers, the rows and the columns are equal. The order 2 by 2, 3 by 3, and so on and so forth. For this program, the maximum we can go is a 3 by 3 matrix. Now, our inverse is actually equal to 1 all over the determinant of A times the adjoint of A. This means determinant of A, and this means the adjoint of A, which is the same thing as C transpose. The C transpose means the transpose of the matrix of the cofactors of matrix A. Now, we shall explain most of these ones with examples later. For the 2 by 2 matrix A, giving A, B, C, D, this is now a matrix A. The determinant of this matrix is simply AD minus BC. What we have done here is the main diagonal, multiply the elements in the main diagonal and subtract the product of the elements in the other diagonal. So we have AD minus BC. The main diagonal comes before the other diagonal. Take note of that. Not BC minus AD. Now, having said that, we have the inverse is calculated using the formula 1 over the determinants times the adjoint or the matrix of the cofactor. For the 2 by 2 matrix, you do not need to bother so much. All you need to do is to interchange the elements in the main diagonal. So you can see A and D interchange to become D and A. Then sign the elements in the other diagonal without interchanging them. Meaning that our B will be signed as minus B, our C will be signed as minus C. If here were minus B before, minus B will become plus. Take note of that. Note, if you multiply a matrix A by the inverse of that same matrix, you will have what we call the identity matrix. Whether the order is a 2 by 2 matrix or a 3 by 3 matrix. I will want to direct you to see related videos on this topic in www.GAPSAcademy.com. You will have more to read and understand on how to deal with problems of matrices. Examples. Number 1, find the inverse of this matrix 3, 2, 1, 4. Solution. Let A be equal to 3, 2, 1, 4. Then the inverse of A is equal to this. And this is equal to 1 over the determinant of A times the adjoint of A. Now, we first of all find the determinant of A, and that will be 3, 2, 1, 4. With this bar, we are defining that is the determinant of A. You can see that we put a bar by A. So this means we can find 4 times 3 or 3 times 4 minus 1 times 2. The result is 12 minus 2, and that is the determinant. So you have known how to find the determinant of a 2 by 2 matrix. Next is to find the adjoint of the matrix A. Adjoint A, as I said, we interchange the main diagonal 4 and 3, and we sign the other elements in the other diagonal, and that is what we have. So your inverse A will now be equal to 1 all over 10 into the adjoint of A, which is 4, minus 2, minus 1, and 3. So you can write this out. 1 over 10 times 4 is 4 over 10, which is 2 all over 5. 2 all over 5. Then 1 over 10 times minus 2, we have minus 1 all over 5. Minus 1 times this will give you minus 1 all over 10. And this will give you 3 all over 10. You open the bracket and close it. That is the inverse of that matrix. Give it to you. Example 2. Find the matrix T if SA is equal to I, where S is equal to this matrix minus 1, 1, 1, 2, and I is the identity matrix. Solution. What you have here is to find the matrix T. And I already told you that your S is minus 1, 1, 1, 2. And then multiplying the matrix here, we don't know what it is, let's call it A, B, C, D. And then the result of this one is equal to the identity matrix, which is 1, 0, 0, 1. If that is the case, so what do we have? To be able to find the value of A, B, C, D, we multiply out this matrix. Minus 1 times A, to have minus 1 times A, that's minus A, and 1 times C is plus C. Then you have the second one, minus 1 times B, minus B, and 1 times D is plus B. You take the other element, 1 times A is A, and 2 times C is plus 2C. Next is 1 times B is B, and then plus 2D. Open and close this to give you 1, 0, 0, 1. Now, what next? You can now equate your minus A plus C is equal to 1. You also have here your minus B plus D is equal to 0. You also have your A plus 2C is equal to 0. Your B plus 2D is equal to 1. So with this matrix, we will be able to find the value of A, B, C, and D. Let's call this one the first equation, the second equation, the third equation, and then the fourth equation. You will now solve. If you take equation 1 and equation 3, you will find the value of A and the value of C. You take equation 2 and equation 4, you will find the value of B and that of B. So let's try and see how this one will be solved. From equation 1 and equation 3, if you look at that, minus A plus A is 0, and C plus 2C will give us 3C. And 1 plus 0 is 1. Therefore, C here is equal to 1 over 3. Then from there, substitute for C in 1, where you have minus A plus your C, which is 1 over 3, is equal to 1. Giving us 1 over 3 minus 1 is equal to A. This, therefore, your A is equal to 2 all over 3, negative. Then you take equation 2 and equation 4. If you solve equation 2 and 4, you can add then minus B plus B is 0, and then D plus 2D is 3D. And 3D, 0 plus 1 will give us 1. Again, our D is equal to 1 over 3. You can now substitute for D maybe in equation 2. In equation 2 you have minus b plus 1 over 3 is equal to 0. In this case, our b is equal to 1 over 3. So at the end, our t will be equal to a minus 2 over 3, b 1 over 3, and then c 1 over 3, and then we have d as 1 over 3. Actually, this can also be written as 1 over 3 into minus 2, 1, 1, and 1. Okay, that is done. That is the matrix T. Example number 3. Find the inverse of the matrix A equal to 1, 0, minus 1, 2, minus 1, minus 2, minus 1, 3, and 1. I want us to take note of certain things I'm going to do now. We know that the inverse of the matrix A is equal to 1 over the determinant of A times the adjunct of A, or 1 over the determinant of A times the C transpose. They are the same. Let's take them one after the other. This is a 3 by 3 matrix. A 3 by 3 matrix. I have already explained to you how to find the determinant of a 2 by 3 matrix. That was not a problem. But when it comes to a 3 by 3 matrix, this is what we are going to do. First and foremost, you have to write the matrix as a modulus, that with a bar. This now says you are looking for the determinant of this matrix. Now, you will take up the signing of the element. The first element carries a positive sign. The second one carries a negative sign. The third one carries a positive sign. If you go down this way, this one will carry a negative, positive, and negative. Meanwhile, this one will carry a positive, negative, and positive. So the sign alternates. So once you take the first one positive, you alternate them accordingly. Now, in finding the determinant of a matrix, a 3 by 3 matrix, you can use any row or any column. You can use the first row or the first column, the second row, the second column, the third row, any of them, it will give you the same result. That is the beauty of this. But I will also let you know that it is always better to use the row or the column that have zeros. Because if you multiply any value by 0, the answer will be 0. So that eliminates that and makes it faster and easier for you. So we are going to use the first row, in this case, to find the determinant of that matrix A. How do we do that? We will start. This is your A, determinant of A. The first row contains a positive sign, so it is plus 1. Then you open another modulus. This line, you will cancel every element on this column and every element on this row, leaving you with the minus 1, the minus 2, the 3, and the 1. Mind you, I did not write the signs that are included in this element. The original numbers are the ones written here. Well, 0 comes in, and I've told you 0 will make everything to be 0, so you don't bother. The next one is plus, and the value there is minus 1. Then you take it up, and what you have here, you cancel everything here, and you cancel everything here. You are left with 2 there, you are left with minus 1 there, you are left with minus 1 here, and then the 3. Mind you, I did not say minus 3. And then I put it back. I will now simplify this. This now has come to the 2 by 2 method I told you of. You simply multiply with diagonals, and then you have 1 times minus 1 is minus 1, and 3 times minus 2 is minus 6. So subtract whatever you have there, which is minus 6. Close this bracket. Now here you have minus 1, open the bracket. 3 times 2 is 6, minus 3, minus 1 times minus 1 is plus 1. So we have plus 1 here. So this is just 1. Okay. Now, what do you see? You have now that this is minus 1, and this is plus 6, and then this is going to be minus 5. The result is that this is your 5, minus 1 plus 6 is 5, and this is minus 5. This will give you 0. Automatically, we are already having a problem, because we do know that division by 0 is not possible. Because at the end of the day, you will need to divide whatever the adjoint matrix is by 0, which is the determinant. This type of matrix is what we call a singular matrix. We cannot find the determinant, the inverse of a singular matrix. So we conclude in this case that if the determinant of A is equal to 0, of course, then the matrix is a singular matrix. The matrix is a singular matrix. A singular matrix has no inverse transformation. The singular matrix has no inverse transformation. So if it's an objective question, you should be able to say it has no inverse. That will be one of the options, probably, in case such a question is posed before you.